Hello, and thanks for joining today. My name is Jeff Demuth, and I'm a technology advisor at Insono. Insono is a company that does manage cloud services, among many other things. I'm based out of Austin, Texas. So yesterday I did a video where I was just testing some write performance between Google's AlloyDB and their cloudsql instance. I was seeing a little bit better write performance on cloudsql compared to AlloyDB. To write a table out, it was a little over a gig and 10 million rows. It was taking about 40-ish minutes, 43 minutes maybe on AlloyDB, and then it was taking about 36 minutes on cloudsql. So better performance there, which is what I expected because AlloyDB has this custom storage engine, and looking at the architecture, it looks similar to Aurora on AWS, where because there's multiple writes, it takes longer for writes to commit. And yeah, so the testing there looked pretty similar. So normally with those, you see better read performance. And today I wanted to test out read performance. And also test out AlloyDB has a capability called column engine. I'm a big fan of column databases, at least for analytics. Right? They've got a purpose. They have a purpose to serve. But yeah, let's take a look at some of the data here because it was surprising. So now with this run here, in the last video, again, so maybe I wrote in a gig of data into the database, 10 million rows. So now to test the read performance, I basically read that original table that had a geometry data type. I generate a geohash off of that geometry and then write it to a new table. So there's still writes at play here, so it's not really a great example of testing true read performance, but I wanted to see what the results were. And actually cloudsql won again by a significant margin. So 19,000 milliseconds for cloudsql to run that query and 46,000 for AlloyDB. And these are smaller instances. I think this is actually a smaller cloudsql instance. I think it's 2 cores, 8 gigs of RAM. I think the smallest AlloyDB one you can do is 2 cores by 16 gigs of RAM. But pretty similar other than the memory. The other thing I'm going to test is, to me it looks like both of these are on the older Google hardware, and I don't see an option to use the latest. It looks like everything's an N2 instance, which is, that platform is like a 8-year-old Intel instance. cloudsql does actually give you the option to select a C4 instance, which should be their latest generation hardware. So if I were to spin this up on a C4 instance on cloudsql, I would expect these numbers to be significantly better. Yeah, I don't know how much better, but going from an 8-year-old Intel to one that's like 2 years old, which is the C4 platform, that's 19,000 on cloudsql. I don't know, it's hard to say how much that would go down, but I think it would be significant. But now let's look at the column engine. So I enabled the column engine here. You can see a couple of the commands I ran just to show that that table has been loaded into the column engine. So I said column engine add geohash, the stgeohash column. I can see that now. Usable status. When I run a query plan, so this is the command to enable the column engine. And you have to be careful with this because if it starts replicating tables into the column engine that have high frequency of change, it'll actually hurt your performance. Then I run the query plan, and we can see that my query that I'm going to test with, it's going to use this custom scan. It's going to use the column scan. So that's where we can see that this query is actually going to take advantage of the column engine. And then the results of that were still very favorable to cloudsql. So cloudsql, in this one, I take the stgeohash column that we created, then actually convert it back to a geometry. So I call geometry from geohash. And then I just convert it back to text because I was worried it was going to not use the column engine if I use geometry, which isn't supported by column engine. But cloudsql ran this command and created a new table in 42,000 milliseconds. And on AlloyDB, it was double, so 82,000 milliseconds. Again, this isn't really a great example for ColumnDB. It is in the sense that this is a small table. So column databases exceed traditional databases when you have very deep tables that are very narrow. Column databases are terrible when you run a select star query against a table that's got 100 columns. This is an ideal scenario because it's a table with 2 or 3 columns and it's very deep. It's 10 million rows. So I would have expected a little bit better performance using the column engine. But I think where column engine is probably going to shine is on joins, when you've got multiple tables that are very deep and you're joining that table, the data against it. But yeah, that concludes my video today. Just wanted to share some of the new benchmarks and testing that I've done today. So with that, thanks for joining, and if you like the video, feel free to like and subscribe. Thank you.